Hi, hello friends. Welcome back to my channel. In this video, we shall learn about sound. It's one of the important concept and easy concept also, which is given in the syllabus of Gpstr exam 2022. So let us recall few basic points about sound. Sound is a form of energy that produces a sensation of hearing in our ears. And we know sound is produced by vibrating bodies. When a body vibrates, sound is produced. And sound requires material medium for its propagation. Either it could be of solid, liquid or gas, any material medium. In vacuum, sound cannot travel. And when a vibrating body causes vibrations in the particle of the surrounding medium, which travels in form of waves with certain speed, this vibration reaches our ear and the sound is heard, right? And we know about the audible range of frequency for humans, that is 20 Hz to 20,000 Hz. Whereas Hertz is the SI unit of frequency, and if the sound range of frequency below 20 Hz, below this 20 Hz, which will not be heard by humans, are called as infrasonic sound. If the sound frequency range above 20,000 Hz or 20k Hz, 20k means 20,000 Hz, is called as ultrasonic sound. Neither infrasonic nor ultrasonic is heard to human beings. Okay, but this both travel in the medium with the same speed as that of the audible sound. Okay, there might be multiple choice questions based on this. Remember, human beings are not able to hear infrasonic sound and ultrasonic sounds, but both infrasonics and ultrasonic sound same travel with the same speed as that of the audible sound. Okay. So as we all know, sound waves necessarily requires a material medium for the propagation. The transfer of energy by the waves is through the vibrations of the medium of the particle about the mean position. So, when the medium of the particle vibrates, there is a change in the kinetic energy into the potential energy and vice versa also. So, sound waves are called as mechanical waves or elastic waves. Okay, and these mechanical waves are again classified into two types: longitudinal and transverse waves. If the vibration of the particle of the medium vibrates about their mean position in the direction of propagation, forming compressions and rarefaction in the medium, are called as longitudinal wave. Okay, if it is about compression and rarefaction of the medium. So you might have learnt about this basics. Okay, just we'll recall about this small little points. And the examples are sound waves in air is an example of longitudinal wave, sound waves in solid and sound wave inside a liquid is an example of longitudinal wave. Moving to the transverse waves, the particle of the medium vibrates normal or perpendicular to the direction of propagation, forming crest and troughs, like this, crest and troughs. Okay, then the sound waves are called as transverse waves. In case of solids, sound waves in solids are example of transverse waves, and sound waves on the surface of liquid are example of transverse wave. Okay, but in case of longitudinal, sound waves in air, solid and inside the liquid. Here, surface of the liquid only. Okay, so these are the examples for mechanical waves, types of mechanical waves and their respective examples. Let us now learn few important terms related to wave motion. Amplitude. The maximum displacement of the particle of medium on either side of a mean position is called as amplitude of that wave. So here we have taken along the x-axis distance and along the y-axis displacement. This is a displacement and distance graph, and as you know, this is a wave and this is the mean position now. from the mean position, which is the maximum displacement, it will be here, right? This highest displacement. This maximum displacement of the particle from the mean position on either sides is called as amplitude. It is represented by small alphabet A, and SI unit of amplitude is meter. Next, time period. It is defined as the time taken by the particle to complete its one vibration. If you take this is up to here, this mark is the one vibration, then we can take according to the displacement time graph. Instead of distance, you write time here. Then the time taken by the particle to complete its one vibration is called as time period. It is represented by capital letter T, and SI unit of time period is second. Next, frequency. Number of vibrations made by the particle of the medium in 1 second is called as frequency of the wave. It is denoted by a letter, small letter f, or we also write like this, nu, N-E-W, nu. Okay. SI unit of frequency is hertz, or we can represent frequency nu is equal to 1 by t. Hence, for t, if you write second, when you take to the numerator, it becomes per second. You can also take as per second is also unit of frequency, the SI unit. Okay. And the relation showing nu frequency and time period is nu is equal to 1 by t, reciprocal of time period. SI unit of frequency is hertz, H-E-R-Z. Next, wavelength. The distance travelled by the wave in one time period of vibration of the particle of medium is called as wavelength. You can observe here. This is one wavelength, and the distance travelled by the particle to complete one time period t is called as lambda, wavelength. It is represented by lambda, and SI unit of wavelength is meter. Okay. Moving to wave velocity. The distance travelled by wave in 1 second is called as wave velocity. And it is represented by letter V. SI unit of wave velocity is meter per second. V is equal to F lambda. This is the relation which shows the relation between wavelength, wave velocity V, and frequency F. It also can be written as V is equal to nu lambda, where nu is frequency. V is wave velocity and lambda is wavelength of the wave. Therefore, wave velocity is equal to frequency into wavelength. And speed of sound is different for different media. So, as we know, speed of sound is different in case of solids, liquids and gases. It is more, the speed of sound is more in solids, less in liquids, least in gases. As we move from gas to solid, speed of sound increases. Okay, so based on that, there are three formulae which represent the speed of sound. In terms of modulus elasticity, if you consider modulus elasticity and density, the speed of sound in a medium is given by the formula V is equal to square root of E by rho, where E is modulus of elasticity and rho is density. So in this, speed of sound depends on two factors, E and rho, where E is respectively V said. And in the second case, V is equal to square root of P by rho, where P stands for pressure and rho is density. This in terms of isothermal elasticity and all we learned here. And in this next case, V is equal to square root of gamma P by rho, where gamma is the ratio of specific heat and gamma is also represented as Cp by Cv. In case of specific heat of constant volume and constant pressure, we go with this formula. Okay, adiabatic changes, that is the Laplace correction and all, we learn this formula. So this all may not be asked. Better to know this basics, right? That's why. These points, infrasonic sounds, ultrasonic sounds and their speed, we have already just now discussed. We shall move to echo now. Before moving to echo, let us recall about a reflection of sound wave. The return of sound wave on striking a surface like a wall, hill, or a plywood, or it could be a metal sheet, anything, back to the same medium is called as reflection of sound. In case of echo, the sound heard after reflection from a distance obstacle like a hillside, wall, cliff, or edge of a forest, etc. after the original sound has ceased, means perished, or it's gone, like that, okay, is called as an echo. Remember, the reflected sound, if heard along with the original sound, it is not called as an echo. When the sound is heard after the original sound is ceased only, that is the sound distinctly separate, means separately heard, that is separate from the original sound, is called an echo. And moving to the important point, that is condition for hearing an echo. Very important point. Pay attention. I have written in short form, so you can just try to make the note and try to understand. To hear the echo distinctly, the following three conditions must be satisfied. The minimum distance between the source of sound, means who produces the sound, source of sound, or it could be an observer, and the reflector must be 17 meter minimum. It should be 17 meter. It could be maximum, no problem. It should be minimum 17 meter distance. So it is different in different medium depending upon the speed of the sound in that medium. Here in case of air medium we consider, okay, remember this. In case of air medium, the minimum distance between the source of sound and the reflector must be of 17 meter. And moving to the second one. The size of the reflector must be large enough as compared to the wavelength of the sound. Okay, wavelength must be small. The size of the reflector must be large. And moving to the third point, the intensity of the sound should be such that the reflected sound reaching the ear is sufficiently intense to be audible. It should be sufficiently intense, okay, to be audible. So these are the conditions must be satisfied to hear the echo distinctly. Okay, among this, if any one condition is failed also, we cannot hear the echo. Okay, all these three conditions are must. Next, determination of speed of sound, that is by echo method. We use this formula, V is equal to total distance travelled by time interval. And total distance, suppose this person is producing sound here, from this initial point to this reflector is d distance. Again this sound should go back to the observer, then one more d distance. So d plus d is 2d. Total distance travelled is 2d divided by time t. So V is equal to 2d by t meter per second. So this is very important formula to calculate speed of sound. And moving to the uses of echoes. Echoes find their applications in mainly sound ranging and echo depth sounding by using ultrasonic waves. Okay. So if they ask in the exam about uses of ultrasonic waves also, you can mention this, or uses of echo by these methods. Using ultrasonic sounds also, you can mention about sound ranging and echo depth sounding. So why preferably we have to choose ultrasonic waves only for this? Here are the reasons. Ultrasonic waves, the properties of ultrasonic waves also we can just mention. Mainly three properties. These ultrasonic waves can travel undeviated through long distance. Okay. Second point, they can be confined to a narrow beam. Okay, straight beam. They will not be separated, like they won't scatter. Third point, ultrasonic waves are not easily observed by the medium. Hence, you can get the clear echo of the sound back. Hence, we choose ultrasonic waves, especially in case of sound ranging and echo depth sounding. Okay. Let's move into the point Uses of echoes by bats, dolphins and fishermen. How they make use of this ultrasonic sounds to identify or detecting the obstacle, etc. We'll check it now. Let's now see how bats make use of echoes in the process of sound ranging. So in general, animals have different audible ranges of frequency. Animals like bats, dolphins and dogs have much upper audible limit frequency than human beings. These bats especially, they can produce very high frequency sound, about 100 kHz. Okay, about 100 kHz sound bats can produce. And these bats, they fly with the speed slower than the speed of sound. Means speed of sound is more, whereas speed of bat, when these bats fly, speed is less. And as it is flying, bats will produce ultrasonic sounds like this yellow color wave you can observe here. And this sound produced by the flying bat gets reflected from an obstacle in front of it. Imagine there is a bee here. Okay, so this is an obstacle now for this bat. So these waves which are produced by the bat gets reflected by this obstacle bee, and it will come back to the bat again. So by hearing this echo, bats come to know that even in the darkness that there is an obstacle present here. Or this could be an obstacle, or even could be an food for them also. It could be a prey for them. Means bat can eat this prey. Okay, so they can fly safely without colliding with the object. If it is an obstacle here, they will not dash to this. Okay, so it will change its path. So on whole, this process of detecting obstacle using the method of echo is called as sound ranging. Okay, sound ranging. Like bats, even dolphins detect their enemies and obstacle by emitting ultrasonic waves. These animals are having the capability to produce the ultrasonic waves. Even bat can produce ultrasonic waves, and dolphin also. So when they produce ultrasonic wave, this wave travel in the medium and get reflected by the obstacle, whatever the obstacle may be. It could be a huge fish or ice, or it could be of small little fishes, anything it could be. So it will be reflected back by the obstacle and reaches back the bat or dolphin. In case of dolphin also detect their enemy and obstacle by emitting ultrasonic waves and hearing their echo. They use ultrasonic waves for hunting their prey. Okay, if this dolphin wants to eat these fishes, it will come to know that there are some fishes here, so it can go and eat those. Okay, even traveler men or fishermen sends an ultrasonic wave pulses from the source. Imagine, as you observe in this diagram, here there is a huge boat, and from this they send ultrasonic waves. And if there is any obstacle, in case of fishermen, they are looking for fish, right? If it is a shoal of fish, group of fish, we call it as shoal, right? So if there is a shoal of fish here, this boat will be sending ultrasonic sounds, and here there are no obstacle, no fishes, so these ultrasonic waves may not return back to the receiver. Okay, but in this place there is a shoal of fish, so the ultrasonic waves sent from this boat, okay, and it is reflected back by this fishes, it will return to the receiver. Okay, so in this case, the distance where the fish, this shoal of fish is located, is calculated using the formula d is equal to Vt divided by 2. Okay, we'll be knowing this with what speed the waves are sent and in which time it to total time taken to and fro, means this time represent the time taken by the ultrasonic wave to travel and to get reflected back and to reach the detector. Okay, this total time t, okay, remember. And we can calculate the speed. In general, the speed of ultrasonic waves in water is about 1400 meter per second. Remember this value. The speed of sound in water, the speed of ultrasonic waves, not sound, the speed of ultrasonic waves in water is about 1400 meter per second. Next, we shall move to an important concept, that is sonar. SONAR. It stands for sound navigation and ranging. SO there and NAR, sonar. We use the formula here, d is equal to Vt by 2, that is to calculate the distance, V velocity time divided by 2, or to know the velocity, speed, rearrange the formula, make V subject to the formula, we get V is equal to 2d by t. Okay, we shall now learn about sonar. In case of sonar, the principle of sonar, which ultrasonic waves are sent into the sea in all directions from the ship. You can observe in this diagram, there is a ship here, and there are 2 points we have to observe. One is the transmitter. From here the waves are produced. This is the transmitter, and there is a receiver here. Here also there is a transmitter. And sonar system, this green color one, middle one is the receiver. Okay, transmitter and receiver. Now when the ultrasonic waves are sent in all the direction, and these waves will be hit by the obstacle. This obstacle could be of either enemy submarines which is inside the water, or it could be of iceberg, or any huge rocks under the sea, or sunken ship. It could be old ship. Okay, so anything it could be. So without damaging, without getting hit by the obstacle, this ship has to travel. Okay, so these ultrasonic waves are sent into the water, and as these ultrasonic waves are hit by this object and reflected back and reaches the receiver, they will calculate the distance using the same formula, that is d is equal to Vt by 2. Just now we have discussed in case of travel men, and so they will come to know that okay, in particular distance that there is an obstacle, so we have to change the path. So the depth of the sea also can be found by this method. So this method of detecting the obstacle in the water is called as echo depth sounding. Echo depth sounding, ECHO, echo depth sounding. Fine. When animals and bats and all, when they produce their own ultra sounds and then they detect the prey or obstacle, that is called as, we have just now discussed that, sound ranging. And here from the system the ultrasonic waves are produced and then it reflects back and received by the receiver. This is called as echo depth sounding. Okay. In case of Titanic ship, if you recall, if you watch the movie, those days there were no systems like this, okay, ultrasound system, and it would have saved if this system was there in long. Uses of echoes also is found in medical field, in ultrasonography, ultrasound scan, that is sonogram, and also it is found in radar. Okay. As we move to the uses of echoes in medical field, echo method of ultrasonic waves, remember ultrasonic waves are used for imagining the human organs like which is inside our body, such as liver, gallbladder, even uterus, and to know the condition of the baby in the mother's tummy. So all this, they use the process called ultrasonography, or this is also called a sonogram. The same method of echo is used when the ultrasounds are sent into the body and it gets reflected by the obstacle or the object which is to be detected, or it is to be analyzed. Okay, and they will receive the respective signal, and based on that they will give the condition of the organs. Okay, even in echocardiography, they use about heart, cardio related to heart, they use the method of echo method is to find the condition of the heart. Okay, so in variety we find all these uses of echo by medical field. So in case of radar stands for radio detection and ranging. The echo method is used to detect the presence of an obstacle and to find its range. But here no ultrasonic sounds are used. Here the sound waves which are used are electromagnetic waves like radio waves or microwaves. Okay, either radio waves or microwaves are used here. So when these waves are sent into the space, after if you imagine there is an enemy aeroplane here flying over, and these waves will get reflected by the obstacle and return back to this radar receiver. So this will detect and we can take the measures later. Okay, immediately they will take the measures. Okay, enemy aeroplane if it enter in its path, and they will check it out and they will shoot sometime. Okay, so in case of both radar and sonar, the transmitter and receivers are placed close to each other, very close here nearby only. Okay, but the difference is in case of sonar, ultrasounds are used. In case of radar, radio waves or microwaves are used. But both the methods of detecting is echo method only. Okay. Reverberation. If there are repeated reflection at the reflecting surfaces, the sound gets prolonged. Then this kind of reflections are called as reverberations. In case of Taj Mahal and Sikandra, we can hear this reverberation again and again. Okay, it is different from echoes. It is repeated reflection after reflecting from the surface, and it is getting prolonged. Let's now move to the differences between sonar and radar. In sonar, in the system operates using ultrasonic sound waves. In radar, in the system, it operates using radio waves or microwaves. In case of sonar, primarily it works in water. In case of radar, it primarily works in air. The frequency which they use in sonar is about 20 kHz to 10 megahertz. In radar, it's about 3 megahertz to 300 gigahertz. The speed of sound, ultrasound in sea, in case of sonar is about 343 meter per second. In radar, it is 300 into 10 to the power of 6 meter per second in air. Okay, so these are the main differences. I think in the model question paper of Gpstr exam 2022, this question is asked to write the difference between sonar and radar. Please check it out. So with this, we have covered important points from the topic sound. I hope this will be useful for your Gpstr exam. There are chances of asking multiple choice questions. Either it will be of 2 marks questions or 3 marks questions also may be asked from this chapter. Very important chapter. You can practice this. Thank you. Thank you for watching. In the following classes, we shall continue with few more classes of maths and physics and important points from chemistry, which will be useful for your Gpstr exam. Thank you.